What is going on, fellow game developers? My name is Muddy Wolf, and in today's video I'm going to show you how you can build your first 3D game just like this one. So you can see here I have a .exe file made in Unity, and here you can see we have a reflex game which will spawn blocks which will slowly get harder and harder over time. So every time we hit a milestone like 10, the spawn rate will increase and we'll be able to basically move. So you can see here comes some blocks, we've got to dodge them, but if we're hit by a block we will then be restarted and our time or our score will be set back to 0. So this is the game we're going to build today, your first 3D game. So guys, if you're excited, don't forget to hit that thumbs up button, subscribe, and let's get on with the video. So the first thing we're going to do is we're going to create a new project. We're going to create a new project, we're going to select 3D, and then we're going to give it a name. So for this one, we're going to call it My First 3D Game YouTube. I'm going to select a new folder for this. I want to go to the D drive, projects, YouTube, Unity, and select that folder to actually add it in. And then we're going to hit create project, and that's going to create us a 3D game we can actually build. Okay, ladies and gentlemen, we are now inside of Unity and we need to do a few things. So the first thing I'm going to do is I'm going to right click, create a 3D object, and I'm going to create a cube. Now we're going to set this scale to be about 15 on the X and about 50, not 50 on the Y, sorry, 50 on the Z axis. We're then going to move the camera up to be about 6, and we'll rotate it on the X to be about 20, so it's looking down. And then if we look at this map, you know what, that's not long enough. Let's make it a bit longer. Let's select the cube and let's make it, let's say 70. Let's move its Z position as well. We just want it to be, so it's about 60. No, that's way too much. Let's say 35, 33, 32, 31, 30. 30 is apparently where we want it to be. And we're going to make this 75 as well. We're going to rename this cube to be ground, and then we're going to add in a new 3D object called a capsule, which we're going to set to reset its transform to 0, set its Y to 1.5, and then we're just going to add in a rigid body, which we're going to turn off use gravity and set to kinematic. And we're going to add some constraints. We don't want any rotation and we don't want any movement except from the X axis, so we can move left and right. And this kind of doesn't look great, as in white on white isn't looking great. So we're going to create a new folder. We're going to call it materials. And then inside of the materials folder, we're going to create a new material, which we're going to call the player. And on this player, I'm just going to set this, let's say to a crimson like color. So let's select this, paste that in. There we go. There's the value if you want to see it. And there we go. Now we can drag this onto our player in our scene. So if we zoom in here, you can see we've dragged that onto our player and he is now a crimsony pink. And let's create a ground material too. So let's create material. Let's call it ground. Oh, and let's set this to some sort of turquoisey color to contrast with this. So there we go. Let's drop that on the ground. You know what, I think once we set the camera lights, we're going to change this to a solid colour, and we're going to set this also to a darker turquoise. There we go. Now that makes it look a lot better. And there we go. So that's our colour set so far. We're going to create one more material, but we're not going to use it straight away. We're going to call it the danger material. And on our danger material, we are going to set it to be a greeny color just to match our complementary colors here. And there we go. So we've got that set. So now we have a capsule which we're going to rename to player. We'll also set its tag to player just because, and we're going to add some new tags as well. I'm going to add a tag called danger, which we're going to use to obviously tell if we've hit anything. So we've got our ground here as well. We don't need to do anything to this. It's just set there just so we have it. And on our player we have a rigid body. So the next thing we want to do is go onto our player, hit add, and let's add a player script which we're going to use to create the movement. So what we're going to do is I'm going to double click this to open it up in Visual Studio Code, which is on the other screen. We're going to close this sidebar, close this, and we're going to delete both the using system tags. And in here, we're basically just going to go up here, go back, and let's get the movement started. So I'm just going to create a serialized field so we can edit inside of the editor. And I'm going to set it as a flow of speed, which we're going to set again in the editor. So serialized field allows you to see private variables inside the Unity inspector. We're then going to create a vector free called target, which we're going to set in the start method. So the start method is called as soon as your player has, your player game object has instantiated. And in here we're going to say target is equal to transform.position because we want the original target to be where we currently are. This target is where our player is going to move to. So we're going to change this depending on what input we give. So next up, we're going to create a update field, and inside the update, this is called once per frame. We're going to say if input.get key down. So we're going to check if we press a key, and we're going to check for the key code A, which is obviously going to be our left key. And we're going to say and if the target.x is greater than -5. We're then going to say our target.x. So our target is equal to or plus equal to a new vector free with -5, 0, 0. So if our target is greater than 5, that means we're currently either the center or the right position, and then we're going to minus it 5. So we're going to be moving our player between 5 units at a time. Then we're going to basically duplicate this, and we're going to say if target.x is less than 5, and we press the D key, so right, we're going to add 5 to our player. No. So if our target.x is less than 5, then we can actually increase it by 5. So we can move it. So if he's on the -5 position or 0 position, he'll be able to move to the center. And then how we're actually going to get our player to move, so we're going to say transform.position is equal to a vector free dot lerp, and now we're going to lerp between 2 positions. So we're going to say transform.position, we're going to say target, and then we're going to say speed times dot delta time. And actually we need to make sure our target is set to its position. Yeah, that's correct. So that should now move towards its position. So let's give this a go. So let's go back into Unity, let the script reload. And then you can see down here, ask for a speed. So we're going to set this to 10 to start with, and let's hit play. Now, if I hit the D key, you can see we move to the right. And if I hit the A key, you can see we move to the left. But if I carry on hitting the A key, we can no longer go too far, so we will not fall off the edge. And you can, sorry, I zoomed in down there. And there you go. You can see we can now move left and right, and only left and right in our position. So now we've got our player sorted, we now need to actually add in a way to spawn the object. So we're going to create an empty object, and we'll call it spawner. We're going to reset its position for now, but I'm going to set its Y to about 1.5. I'm then going to move its Z position to about -65 or 65. Let's have a look what this looks like. Oh, we're not quite there. Let's say 70. No, 65. You know what? Let's add in a little icon here. So you can see here we have these icons. If I select the red, you can see a dot. And actually, 65 seems about right. It looks like it's in the right position to spawn the objects down here. So that's great. So now we've got our spawner down there. What we want to do is we want to add in a spawner component. So let's create the spawner script, create an add, select the, double click the spawner here to open it up in Visual Studio Code. We're going to delete the system.collections.generic, but we're going to keep systems.collection because we're going to be using arrays. We're going to remove the starting code. And then inside of here, I'm going to say serialized field, vector free array, and I'm going to say spawn point. So this is going to be the points our object or our prefab can actually spawn. So the block will only be able to spawn at the spawn points, which we can set inside of the inspector. We're then going to create a game object called prefab, which is obviously going to be all our block prefab, just so it's named a bit better, just so we know what we're actually going to be spawning. So this is going to be the object that we spawn. We then want one more serialized field called a float array of spawn rates. Now we're going to use this to change the spawn rate depending on what stage we get to in our game. And then we'll create a private float called spawn rate singular, just so we can actually set the actual spawn rate dependent on the spawn rates. Oh, and actually we do need one more. I'm just going to pull it below the block prefab. We're going to say serialized field, and I'm going to create a score counter called SC. Now this isn't available yet, so we're just going to uncomment this out, but we're going to create a score counter class or script soon to be able to use that. So inside of our start method, we're going to say our spawn rate is going to be equal to spawn rate 0. We're then going to say start coroutine, which is going to allow us to call a function over and over again. So it will basically, we can now basically set a timer for it to spawn. So we can now go down here and say an IE numerator spawn, and we're going to say while true because we don't want it to end. So while this is true, we're going to yield return a new wait for seconds, and we're going to create a random.range here, which we're going to say spawn rate minus 0.5 or spawn rate plus 0.5. So what we're doing is we're saying whatever the spawn rate is, we're going to give it a bit more randomness and say it can spawn either at minus 0.5 of a second off the spawn rate or at the spawn rate. So what's happening here? So this spawn, we're checking. So we're going to call start coroutine, which is basically going to start this spawn method. So while this is true, this will run. So this is always going to run. Now you can add a variable here that you can change to stop it running, but for now we'll leave this as true. And then yield return wait for seconds is basically going to make the script wait before actually rerunning or before continuing on with the code. So we're going to wait for a random range, which is here. So we're actually going to put this in a variable. So let's create a float, and we'll call it spawn time, and we're going to set it equal to the random range there. So you can see here we can now pass through the spawn time inside of here, which will get randomly every time. Once we've waited seconds, we're going to basically say instantiate, and we're going to pass through our block prefab. We're going to say spawn points random range from 0 to spawn points.length. So I mean basically we're going to find a random spawn point and we're going to spawn at it. And then we're going to say quaternion.identity to give the block its default rotation. So this is just going to basically give us the default rotation of the current block prefab. So you can see your spawn points, and then we're going to say random.range, whichever spawn point we want to spawn. And that's basically going to create a block and spawn it in. And that's all we need to do for this script. For now, we will need to add in the spawn rate increaser once we've built the score counter. But for now, this is fine. So let's go back to our game. And let's create a new 3D object called cube. And let's just call it a block. Now, we're going to set this tag to danger because it's going to have the danger tag. Let's reset its transform here and just give it a bit of space on that. And also set that to about... Y to about 2, and that to 0. You know, I think 2 is a good height there, and we'll set that to 6, just so we can see it. So you can see the block there. Let's drag on the danger color to it, so we can actually see the green block. And then what we want to do is we want to add a rigid body to this block, which we're actually going to turn off. Use gravity and turn on is kinematic again. And we're going to say it's constrained. So this time we're going to constrain everything but the said position. And what we're going to do is we're going to turn this into a prefab. But first, let's create the block script. So this block script is how we're going to move the block towards the player. So inside of here, we can delete the using tags again. Bring up this and delete this. Just deleting all the codes there. We're then going to create a serialized field. We'll say float speed, which is going to obviously be the speed of the block. And then we're going to create a rigid body called RB, which we're going to use to obviously add forces. So a rigid body allows you to add physics to your game object. We're going to create a fixed update method, and we're going to say rb.velocity is equal to minus vector3.forward, which is the z axis, times speed. So we're going to basically say we're going to add a constant velocity, so this block is always moving at the same speed, of vector3.forward, which is on the z axis, as you can see there, or vector3.c. And then you can see we're going to set minus because we want it to come towards the player, so we want it to come negatively towards the player. And then we want to say times the speed to actually give it some speed, so it's a bit faster. And that's all we need to do for the block field. So let's go back into here. Let's click on our spawner, and now we need to set the spawn point. So let's add 3 of these. Now the first one is going to obviously be, we need to obviously get these values from the spawner. So we need to say, we're going to set this to 2. And we'll get this and set these to 2. And this to 65 for every single one of these. Because this is the position we always want to make. But now we want to set the X to -5 and the, the first one to -5 and the last one to 5. Which will now give us a, it will spawn in 3 different positions. So either -5, 0 or 5. We're then going to turn this block into a prefab we can spawn in at any point. So we're going to drag this and drop it down into our project here, which is going to create a prefab. We can then delete the one from our scene, and then we can click on our spawner, and where we have the block prefab, we can actually drag in the block there to actually add it. We're then going to set some spawn rates. I'm going to set 4 of these, and the first one is going to be 1.25, the second one is going to be 1. We're then going to have 0.75 and finally 0.6. Now, I can't do 0.5 because that will give it a 0, be able to spawn at 0 interval, meaning they could spawn 1 block inside of another, which would not be great. So we have to slightly offset at 0.6. So there you go. So that's what we need for our spawner. Now, if we hit play, you will see, or should see, RB of block has not been assigned. So we need to go back to our block prefab, and where we see our rigid body, we need to drag in our rigid body and actually add the speed to, let's say, 10. Now if we hit play, we should see that the blocks spawn in, but they're not moving. So why are they not moving? Let's find out. Alright guys, I just realised I set this to is kinematic by accident. This only the player needs to be is kinematic, whereas the blocks need to obviously not be kinematic because they are going to be controlled by physics and not by the script. So we're going to say here is kinematic is not equal to true, and now if we hit play, we should see that the blocks start coming towards us. Now I think this is quite slow, so I'm going to set these to 15 by default. So now when they spawn, you should see they are a bit faster. And you have to dodge these blocks, which make it a lot easier. So if we make sure this is set to 15 and the tag is danger, there we go. So one issue we're going to have is when one of these blocks comes to actually hit our player, it's not going to do anything. It's just going to stop and they're just going to stack up, which, I mean, looks kind of cool, but that's going to cause some obvious issues. That's not a game. Let's hit stop and let's go to our block. Or our player script, sorry. So double click this to open it up. And what we're going to do is we're going to go down below update and we're going to create an on collision method here. So we're going to say on collision enter. We're going to say if other.gameObject.tag is equal to, and we're going to say danger. We're then going to say destroy our current game object, and then we've got to reload the scene. Now to reload the scene, we need to take the using tag and we need to say .scene management. And what we're going to do is we're going to say scene manager.load scene manager.get active scene. So this is going to get our current scene, And then we need to just get its build index so we can actually reload the current scene. Now this may not work because you need to add in your project settings. So if you go to, you go to your build settings, you need to add in your scene to your build settings. So where you see sample scene, we're going to drop this in here and we're going to close that. Then what we're going to do is we're going to hit play. And then when a block hits us, so let's wait for this to hit us, we should see that our game reloads and it's continuing playing. But you're going to notice the lights are gone. Now this isn't an issue because our game, once we actually render this game out or export the game, it should fix that issue. But in case it annoys you, we can go into our rendering, lighting, go into scene, turn off auto generate if it is on, and then hit generate lighting. Now this is going to generate some lighting data, as you can see down here in the scenes, some lighting data that will allow us to, now if we hit play and we die, it will basically keep the same lighting effects as before, which is great. So as we get hit, you can see the game still has the same lighting it had before. And there you go. Now the game is loading and we actually have a game loop. So this is essentially a game in theory, although there's no score, there's no fun elements to it. So let's actually start making the score. So what we're going to do is we're going to right click, click UI, and we're going to select text. Now inside of text, I'm just going to rename this to score. And in our canvas, we're going to select 2D on the scene to turn it into 2D mode so we can actually zoom out and see this. And we're going to go to canvas and change scale with screen to 1920 by 1080. And I'm going to set this to 0.5 just because I prefer it like that. I'm then going to select score and I'm going to set this to the top of the screen. I'm going to set this with 300 by 300 by default. So the sides, you can see the rectangle down here. We're going to set the color to be white, the font to be bold, and we're going to set it to be best fit, and we're going to align it center. We're going to set this to be 200, and then we're going to set the score to be 0 by default. So now you can see up there that this actually looks good. It's just set as 0, but we need to obviously update this. So what we're going to do is we're going to create a script on here called score or score counter, which we're going to click create and add, and we're going to double click this to open it up in Visual Studio Code. Now we can delete the 2 using tags, but we do want to get the using Unity engine.ui to get the UI elements. Let's remove this here, and now we need to get some references. So we need to say serialized fields, text is equal to score text. We're then going to create a public float. Now the reason we're making this public is because we want to access it in other scripts. So we're going to say score is equal to 0 by default. We're then going to create a FOI or create an update method, which we're going to say score is plus equal to time.delta time. And what time.delta time does is it basically the interval in seconds from the last frame. So it actually tells you how long it's been since the last frame, and it gives us that, which overall will add up into 1 second once it's all. Every time you add it, this will equal up to 1 second. We're then going to create an onGUI method, which basically says update the GUI or graphical user interface. So anytime this is called, we're going to say score text.text is equal to math f.round to int, and we're going to pass through our score. We're then going to say .toString because obviously text requires a string. And there you go. That's this now finished. So if we go back to our game, you can see it's going to ask us to pass in our score text, which is right here. So let's drag it in and let's hit play. Now, as you can see, as the game goes on, this is going up one per second, and there you go. But if we die, it restarts. But now let's make our game more difficult. Now we've got our score counter, we can actually go into our spawner and actually use the spawn rate. So let's double click this to open it up. Let's change our score counter to be uncommented. And then we're going to create an update method. And inside the update method, we're going to say if score.score is greater than 10 and the spawn rate is equal to spawn rate 0. So if we're at the first stage, we're basically going to say spawn rate is equal to spawn rate 1. And we can then do an else if score is greater than 20 and spawn rate is equal to spawn rate 1, we can set it to 2. And finally, we can say if score is greater than 30, we can set the spawn rate and it's equal to spawn rate 2. We can set the spawn rate to the third spawn rate, which is actually the fourth spawn rate inside of our array. So you can see here we have 4 spawn rates, but they all start off obviously at 0. So it goes 0, 1, 2, and 3. And now if we turn on debug mode, you can actually see the spawn rate down there. So if we hit play, you should start seeing the spawn rate changing. So after 10 seconds, so let's dodge this. Obviously 10 seconds is a long time. You can see it's now gone, it has not gone down. So there's obviously an error. You can see there's an object reference not set instance. And that's because our spawner, we need to obviously set our score there to have our score counter. Now we can hit play and this should now work. So there we go. Now it's now 1, and if we get up to 20, it should change to 0.75. Which it has, 0.75, and if we get up to 30, we should now start seeing the spawn rate will go down to 0.6, which is the fastest spawn rate we can have. And there you go, it's at 0.6, and I clicked off the screen and we died. But we saw the spawn rate was working and it's going to get progressively harder. Now, one issue we have for our game is you can see here, we're just creating block clones, which is just forever going to build, which is eventually going to lag your game, especially if you're on a not so powerful PC. So one thing, there's 2 things we could do. We could either create an object pool, which is the right way to do it, or we can take the cheeky way and just create an area where if the objects go into it, they get destroyed. So I'm going to do the cheeky way just for the purpose of the tutorial, or just because creating a pool is a whole different game on its own. Let's just hit F on the player to move in. So we're going to create an empty game object, and we're going to set this to be called GC, which is garbage collection. I'm going to set its X position to 0, its Y to -1, nope, 1, and it's set to -10. Maybe even -9. There we go. So it's right at the end there. Now we can add a component and we can call it GC, which is garbage collection. Hit enter, double click this to open it up in Visual Studio Code. And now I'm just going to go in here. I'm going to remove this. We can delete the using tags. And this is as simple as saying on trigger enter, we're going to say if other.gameObject.tag is equal to danger, then we're going to say destroy other.gameObject. And that's just going to get rid of the game object. Now, this isn't the most performant way to actually deal with this, but object pooling is a completely different ball game, and it's a tutorial on its own. So I'll go over how you can actually object pool in the future to make this a lot more performance. But for the style of this game, for how simple it is, you shouldn't have too many issues with performance. So if we go to our player, go back to Unity, there's a couple more things we need to do to our script here. We actually need to add a box collider and set it to trigger. And we obviously have to scale this up. So I'm going to set it to 15 on the X. So you can see the green is that. And let's say 3 on the Y. And let's set it to 1.5 so it's now in line with the ground. So now that should catch. Actually, that could be 2. And there we go. That's in line with the ground. And we can obviously put this at -8 to bring it in right up to the end of the wall there. Now, we should be able to, see from here that our objects get destroyed. So let's hit play. And now if we successfully dodge the first few blocks, we should see on our screen here that when they hit the wall, they die. So as you saw, they get removed from the game. If I just move out the way here and dodge for, you can see at the bottom screen, they actually get destroyed as they hit this wall, which is perfect. So guys, that is basically how you make the game. Now let me show you how you can export it. So if we go to our build settings, and inside of here we can see we're setting this for PC, Mac and Linux. Obviously if you want to do it for Android or web, you can do that, but you obviously have to learn how you use the input, so you might want to change how it actually works if you go for Android or iOS. And obviously for WebGL it will be the same as PC's input. So what we're going to do here is I'm going to select the target platform, which is obviously Windows. I'm going to leave this as it is and I'm going to hit build. Now it's going to ask me where we want to save this, so I'm just going to create a new folder called build, select it, and then obviously this will now start building our game. So as you can see guys, this is built and it opened up this, and we have it here. So if we double click this now, we can actually, this should open up made with Unity splash screen, and there we go. We now have a working game we can send to our friends and let them play. So you can see here, we can just dodge all the blocks, have some fun. Obviously this game isn't too exciting, there's a lot more you can do with it, so don't forget to make some changes, make it yours, have some fun with it, try out some different things, and I hope to see all your awesome games in the future. So guys, thanks for watching this video. If you liked it, don't forget to leave a thumbs up, smash that subscribe button, and I will see you in the next one. Peace out.